Hello, everyone. Welcome back to SAT Math Question of the Day with Professor Emeritus Seth Chaiken in University of Albany and Seth's brother Joel. We're here to hopefully show you how to approach both studying for the Math SAT and actually how to approach Math SAT questions. On the studying side, Khan Academy has partnered with the College Board who makes the SAT, and basically they are telling you what is on the test, and they're giving you a lot of questions on each topic. So we strongly encourage you to go to Khan Academy and do the practice questions. It's all free. If you want to see how to get there, watch our video dated June 29, 2023. So under that vein, today we are doing an advanced question. We only do the advanced questions now because we spend so much time going over how to do them. Presumably, if you're following us, then you can do the medium and the foundations questions yourself. Okay, so today we are doing advanced problem solving. We do one question in each one topic a day. So yesterday we did rates and ratios. Today we're doing, yesterday we did rates, ratios, and proportions. Today we're doing unit conversions, which are essentially ratios, aren't they? Unit conversions are essentially ratios, right? Ooh, tomorrow's percentages. Whoa, okay, fine. So today we're doing this. This is our first time doing unit conversions. So let's go. Well said. Okay, this is our first question. Please, it's really the only question we're going to do. Please read it, try it yourself, come back to the video, and we will go over it. Speed of sound at sea level is about 343 meters per second. What is the speed of sound at sea level measured in kilometers per hour? Fine. So this is a very, very standard unit conversion problem, which we've done previously on the non-digital side. Classically, you do this with unit analysis. Is the most efficient way to do this, right, Seth? Just applying the method of unit analysis and just writing out all the different ratios.
Let me. Do you mind if I do it, without formal unit analysis?
Yes, as long as you'll let me do it.
Yes, of course.
After we're done. Okay, good. Good deal.
So the speed of sound is 343 meters per second. Okay. So in 1 second, sound goes how many? 343 meters.
Right.
Okay. They're interested in how many kilometers it goes per hour. So in 1 second, it goes 343 meters. Well, how many kilometers does it go in 1 second? In 1 second, sound goes, a kilometer is 1,000 meters. And so it goes 343 thousandths kilometers, right? And that's in 1 second. Now they're interested in how far does it go in an hour? Okay, so we take the amount of how much it goes measured in kilometers in 1 second and multiply that by the number of seconds in an hour. Okay, and they told us 3,600. So the answer is 343 times 3,600.
Right, you mean 0.340.
Yeah, 433 thousandths.
Yeah.
It's also known as 0.343, which is 343.
Right, so I'll bring out a trusty calculator.
1,000ths, written in decimal, times 3,600.
So it happens to be, wow, they want you to do exactly, so it turns out to be, I'll write it up here,
and then
1,000.
round it to a whole number.
Oh, they
All
say
right.
wait, they say rounded all right. It's okay. The calculator will say that's what we needed to know is what do you round to? It's 1,234.8. So the answer, which we'll put in here, is 1, 2, 3.
Yeah.
I like the way you did it. You used intuition, common sense. It works really well here. What I would say is if you want to do 343 meters, how many kilometers it is? Well, it's not more than that, so it has to be less than that. So it has to be a point three
Yeah.
four three.
Got.
And if something
Well, common sense. A kilometer. Kilometer. It's
kilometers
1,000
big,
meters. A
kilometers big
meter.
compared
How
to
much
feet,
is a meter?
about 3 yards,
No, 3 feet.
3 feet, right?
It's
Yeah,
39.38 inches.
right, right,
3 inches over 3 feet.
right.
It's about a yard.
Yeah, about a yard, right?
And
Yeah.
1,000 of those is what? About therefore
About 2 miles.
1,000 yards, about 3,000
Oh
feet.
yeah,
So
yeah,
it's
yeah.
about 3/8 of a mile.
Yeah, about that's right. It's not 1760
Yeah,
yards
so a
a mile.
meter,
Right? Yeah.
you'll bring up your heart rate and breath if you run for a meter.
Yeah.
It's like, I don't know, a few blocks. A kilometer.
A kilometer, right? Yeah, yeah.
So it's a lot. So the sound goes a lot further. 1,000 times further.
Right.
No. If it goes a certain hundreds of meters, well, that's only a fraction
Right.
of a kilometer.
Of course, that's why common sense works. Yeah.
Yeah, yeah.
And then also, Seth was very sensible. In fact, Seth didn't even have to go through all this stuff. But if something moves something in 1 second, then in 1 hour it multiplies 3,600 times that. Because if it does
Yeah.
something in 1 second,
Yeah.
multiplies by 3,600. Yeah, this makes sense.
Yeah.
So this is
Now, when I got to
Yeah.
this point, number of seconds per hour, I got worried. I'll have to figure out the number of seconds in an hour.
Yeah,
No, they gave it to us.
They gave it to you. So what's great about this is it's very fast. It uses intuition. The only unit analysis has one advantage, which I think, although frankly, this is a really good way to. This is why smart people do this problem. The doing it methodically through unit analysis has the advantage that when you have a problem which doesn't have a lot of intuition, then unit analysis is more methodical and keeps you in line. For example, if it went 0.0001 something or some crazy units that you have no understanding of them, it's a little harder to understand how to do it this in Seth's way.
Well, in doing science, unit analysis is very helpful to check that your formulas make sense.
Yeah. So what is all this unit analysis stuff? So okay, I'll try to write very neatly.
So let's do it by unit analysis.
Unit analysis, fine. So this is the way. This is a very powerful method. First, you put an equal sign there. Now,
Joel, I think you should just clear the screen.
Okay, sure. Yeah, we'll clear the screen. Good suggestion, so. Okay. Okay, fine. So first, everybody does unit analysis slightly differently. I start with the equal sign. So what do we want to end up with? We want to end up with kilometers per hour, right? And we know they're going to be a bunch of ratios here. Who knows how many yet? We want kilometers per hour. What are they giving us? They're giving us meters per second. Okay? They're giving us actually 343 meters per second. Now, we want the kilometers to be in the numerator. Here, the meters in the numerator. So we put a meters here and a kilometers here, which means that we do the best thing in the world. We get to cross out the meters, and we're left with kilometers, which is very nice. Now we ask ourselves, how many meters are in a kilometer, or how many kilometers in a meter? Let's see. 1 kilometer is 1,000 meters. Okay, so we did that. Now, we're left with seconds in the denominator, but we need hours in the denominator. So we put a seconds here, and we put an hours here. So we could cross out the units. Very cool. That's now an 8, but it's not an 8. It's an S. So it's crossed out. Okay, crossed out the S's. Now, this is S. Now, how many seconds are in an hour? How many hours in a second? Think about that. We got 3,600 seconds in 1 hour. So we've crossed out the seconds, we've crossed out the meters, we're left with kilometers per hour. So then we just multiply all these numbers. 343. This is where the calculator comes in. 3,600 divided by 1,000. So then you can just do that. 343 times 3,600 divided by 1,000, and you get the same answer. Round it to the nearest number. The whole number is 1, 2, 3, 5 kilometers per hour. Interesting. H. Normally you say HR for hours, don't you? I don't know. Whatever. Doesn't matter. So, you would probably not do 2 consecutive ratios problem. Well, that's essentially what you did, Seth. You did 2 ratio problems, one after the other. Sort of.
Yeah.
Sort of.
Yes.
Yeah. Yeah, except, yeah. So that's the other approach.
Yeah.
So, okay. So they probably did it.
The problem at hand, the strategy involves 4 ratios. You combine 3 ratios. You multiply 3 ratios to obtain the answer, which is the 4th ratio.
Yeah. And that makes sense because you did it in 2 ratios.
So speed is a ratio.
Yes.
It is a ratio of some number of some unit of distance divided by or to some number of some unit of time.
Right. Yeah, it's a ratio. So unit conversions are essentially ratio problems. In fact, my suspicion, so tell me what you think about this, although you're not going to like what I say, that if you don't do math professionally, you don't do science professionally, you just literally do a career like that uses no math professionally, the most common math problem you will find is a ratio problem in your life. Like when you go shopping, if ratio problems are all over the place. How long does it take to go somewhere at a certain rate, or how much money does it cost to buy a certain number of gallons of gasoline, or apples, or shopping? Right?
Yeah. So if they say, apples, or actually, I went shopping today and they were selling, how much? 2 red peppers for $3.
Yeah.
And I bought 3 red peppers.
Yeah. So.
Yeah.
Okay. So let's see how they did it. Too bad they don't give multiple approaches, because it's something to understand. Is in math there are usually one approach to do a problem. And it's not a bad idea, if you can, to think about the different approaches that you would take.
That's why we do this video.
But hopefully maybe it'll become people think about, it's like they can start thinking about how to do a problem more than one way. If you hopefully have time when you're doing your homework or studying, hey, I could have done it this way.
And it may be a good idea, to visit multiple approaches.
Yeah.
But then decide for yourself what your favorite is.
That's right.
And then use your favorite approach.
Yeah. But Seth didn't.
I think there is something to be said for the practice of picking or memorizing a single favorite approach, so that you could apply it, without worrying about it, and apply it efficiently. Efficiency is important, because these little problems like this. Often in practice, in the real world, a problem like this is just a tiny sub problem of a more complex problem.
Okay, so let's see how they did it. Be interesting. It'd be interesting to see how they did it. They probably use unit analysis, but let's see.
Well, let's see.
Let us see. Okay, so we type in. Oh God, what was it? It was 1230. It was 0.3. I remember the it was 12,128 something. Times 3600. Okay, so it's 1, 2, 3, 5. Okay, 1, 2, 3, 5. Here we go. Check. Okay. Notice that's so funny how randomly it says, "Do you want to see how we do it or not?" Sometimes they don't give that, so let's just do this. Only 2 steps. So they did unit analysis. They did it the second way.
There we go.
They did it.
That's Joel's way.
They did it Joel's way.
Yeah. Very good.
Yeah, I guess they want to be a little methodical about it.
Yeah.
But I like Seth's way. But Seth's way only works when you can apply common sense.
Let me explain it in terms of my way.
Good. Go ahead.
We start with 343. It goes 343 meters in 1 second. We're interested in the number of kilometers it goes in a certain amount of time.
Right.
Well, the number of kilometers, kilometers it goes is 1,000th of the number of meters. And that's this ratio. So this product, this is the number of kilometers.
Right.
The number of kilometers per second.
Yeah.
So we converted 343 meters in a second to 1,000th of that, which is 343 thousandths kilometers per second.
Yeah, that's exactly.
Then we take this is a solution. This is the number of kilometers it goes in 1 second. We multiply it by the number of seconds in an hour.
Right.
This is the number of seconds in 1 hour.
Right.
And therefore, we same thing. So it's the same product. You both 343, right, times 1,000th. And that's the first calculation I did. And then you multiply that by 3,600. You get the answer.
Yeah. Yep. Sometimes in the lower grades, when they teach unit conversion, you may want to go 12. Oops. This is not a great way to do it. It only works under certain circumstances. Let's say you have 12 dozen per hour, and you want to go how many units per second, right? You can then cross out the dozen and say, well, the dozen are 12 units. We're just throwing out the word dozen and we're substituting it with the word 12 units. And 1 hour, when I cross out 1 hour, 1 hour is equal to 36 seconds. So then the answer is 12.
Hold on. You need to have another multiply by 12.
Yeah, it's 12 times 12 divided by 36.
Oh, there's a multiply here.
Yeah, there's a multiply there. Yeah.
That's not an equal, so it's a multiply.
Yeah, I'm sorry. You're right. So it's a multiply.
Yeah.
That's a flaky way to do it. This only works when you're going from big units to small units. You got a little bit of a problem
Yeah.
if you want to go from seconds to hours, right? If this is seconds,
Yeah.
and you want to change this to hours, then what do you cross out the seconds? You're going to cross out the second and put 1 over 36 hours. It's a little flaky, but this works sometimes if you can get away with it. You just cross off the unit and throw in another unit. But it really only works when you go from big to small. So, anyway. Okay. So I guess that's it for today, right?
That's right.
We're done. Ollie, 20.
Well, tomorrow we do Throwback Thursday.
Tomorrow we do Throwback Thursday, yeah, where we take a question from the pre-2016 test, usually from the early 2000s. And it's more of a reasoning test. And we will go over a question like that. Plus, we will do the next topic in line under the digital SAT practice. So, I guess that's it, right? Have a great day. Please like us, dislike us, give us comments on our YouTube videos, and please email us your SAT math questions at satmathquestionoftheday@gmail.com. Everybody, have a great day.